Good day everyone! Today, we'll be presenting our robotics experience, focusing on the input system we use and how they work together in a complete system. In robotics, input systems are very important because they allow users to interact with the Arduino activities or systems. We use three main input components: the RFID sensor, the 4x4 keypad, and the IR receiver. Each of these components allows the system to receive commands in different ways.
The components works. The RFID sensor works by reading a unique ID star in a RFID card or tag. When the card is placed near the reader, the sensor reads the ID to Microsoft controller which checks if it is authorized before allowing an action. Times or keypad allows user to input data by pressing keys. Each key pressed is detected by the microcontroller through row and column scanning, making it suitable for entering password form. IR receiver detects infer signals sent from a remote control. When a button is pressed, the receiver reads the signal codes and sends it to the microcontroller, allowing wireless control of the system.
Debugging experience. During the project, we faced several technical challenges such as incorrect wiring and response, components and signal detection issues. Since our group was a collaboration of Kit 5 and 3, and here are the activities that we experienced problem. In Kit 5, the first is the activity 3, the keypad, because our keypad that we use is full, and also in Kit 3 is on our RFID activity 4 because of not familiarizing the name of tag, and the servo that we use is 360 degrees, so we need modify the code. To solve this problem, we test each component individual, check our connection, and use serial monitoring to verify incoming data. This step helps us identify errors quickly. One important lesson we learned is that debugging is such when components are tested one at a time before system integration.
After testing each component separately, we integrated them into one system, the RFID sensor and keypad with output components, such as servo motor, LCD, and a buzzer. In these components, we can make an Arduino-based smart door lock system. This servo will open and lock the door. The LCD displayed system message and the buzzer gave audio alerts. This feedback helped us understand whether the input was successfully received and processed. We also learned that starting with supplier systems such as RFID with an LED made it easier to later develop a more complex system like an RFID-based door lock.
Practical applications. These components have many practical applications beyond our project. RFID sensors are commonly used in access control system, attendance tracking, and contactless payment system. Keypads are used in digital locks, ATM, and security panels. IR receivers are used in remote control devices, robotics, and home automatic systems. When combined, these components can be used to build advanced systems such as smart door, locks, multi-input security systems, and interactive robotics platforms.
One successful moment in this project was when all the components were together created in the single system, setting the system responded ability to RFID cards, keypad input, and AR signal showed that your integration was successful.
There was also feature moments as when components did not respond correctly when to warning mistakes or small coding errors. Those moments were challenging but happened us understand the importance of honesty and careful testing. From this project, we learning the testing components individual using feedback devices and doing step by step are essential in robotics. Failure in part of the learning processes. From future student, your advice into start sync ready device create for test each component separately and not rush the ignition process.
In conclusion, the RFID sensor, 4x4 keypad, and an IR receiver are powerful input system in robotics. By understanding how they work individually and how they integrate together, we were able to create a functional and interactive robotic system. Thank you for listening, and that's all. Thank you.